Today we'll be going over Leetcode problem number 977, squares of a sorted array. We'll start with the problem readout, then we'll move on to whiteboarding, and then finally we'll code out the solution. So let's give it a quick read. Given an integer array nums sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. So I'll be given an input which will be an array of integers that's sorted in an increasing order or non-decreasing order. And these elements can be negative and positive. And the output will be the squares of all those integers, which is sorted. So after squaring, the array becomes 16, 1, 0, 900. After sorting, it becomes 0, 1, 9, 16, 100. So if you look at the constraints, it says nums.length is between 1 and 10 to the power 4. And each element is between minus 10 to the power 4 to the 10 to the power 4. And my input is always sorted in increasing order. We'll also notice the follow-up here. Squaring each element and sorting the new array is very trivial. Could you find an O of n solution using a different approach? So we'll talk about the O of n solution and not the squaring each element and then sorting the new array solution. So let's do a walkthrough. So this is our input array, minus 4, minus 1, 0, 3, and 10. So the idea here is you need to be able to keep track of which element gives you the highest value when you square them. So for example, if I look at 3 and minus 4, squaring 3 would give me 9, but squaring minus 4 would give me 16. So I can't just start squaring from the right and the left and then hope my output would be in the correct order, because the magnitude is what we're looking for, right? So what we're gonna do is we'll allocate the memory for the solution first, then we'll use 2 pointers to keep track of where we are in the input array, and then based on the value of squaring the each number of both indices, we'll figure out where to put it in our output. What do I mean by this? So initially we'll start by allocating the memory for the output. So we'll call it the res array. And res would be equal to an array which has the same number of elements as the input array. So I have here 1, 2, 3, 4, 5. So this would be equal to 5, an array with 5 empty elements, or you could initialize them to 0 as well. It doesn't really matter, so I'll just do 0, 0, 0, 0, and 0. So we'll have the same number of elements as our input array, because once we square every element, we would want to place them in here. Now what we'll also do is we'll need to keep track of where we are in the output. So I'll call it res index. And we'll be moving this as we go along. Now for the input array, this is the nums parameter, right? So we'll have a pointer for the right side. I'll call it R. And we'll have a pointer for the left side. I'll call it L. Okay, so the idea here is for each of these elements, we'll square them both, figure out which one is higher, then make the change in the output array, and then finally we'll move the pointer to the next location. So what do I mean by this? So for example, let's say we start at minus 4 and 10. So if we square minus 4, we'll get 16. But if we square 10, we'll get 100. So the idea here is to figure out which one of these is higher. So if this is higher, then this would go here. If this is higher, this would go here. So we know that 100 is greater than 16. So we replace the 0 in here with 100. And then since we have already used up this element, what we have to do now is we have to move this to the left. We'll keep the left here because this may be higher than this, so we don't add the 16 immediately. Now after we do that, what we'll do is we'll also update the current index of the output. So I move it to here. Now we're done with this, so I'm gonna remove this, and then we're in a second loop, right? So again, we check which one is higher. So we do -4 square is equals to 16, and then we do 3 square, which is equals to 9. Now we check which one is higher. We see 16 is higher than 19, so we're gonna change the 0 to 16, and then we will move the pointer. Oops, I'm sorry. We will move. So we'll move the left pointer one step to the right because we're done with this element. Now after doing that, we'll also have to update this index. So what we're going to do is we'll decrement this by 1. And notice that our res array is starting to look like the output array. So I'll go through rest of the process a bit quicker right now, so hopefully it'll make sense. So -1 and 3. If I do -1 square, it gives me 1. If I do 3 square, it gives me 9. Now 9 is greater than 1, so I replace the 0 with 9. Then I move my right pointer to the left, and then I also move my res pointer to the left. Again, we check the new elements at these two indices. So we do -1 square is equals to 1. Then we do 0 square is equals to 0. Now 1 is greater than 0, so we update the position in the res array to 1, and then finally we move this. We move the left pointer to the right. Now you'll notice that both of these are at the same location. Now we will still square this array, right? And once they move over from each other, then we'll stop the looping. So at this position, both of them are 0, so 0 square is 0, and then 0 square is 0. Since both of them are the same, we'll update the final location with 0. Since we already initialized it to 0, this is fine. Now if you look at the res array, you'll notice that this is the exact same output that we got from the example. So we'll write out this solution right now. And notice that for the next iteration, this moves over. So when left becomes greater than r, that is when we stop looping. Or in other words, while the left pointer is less than or equal to the right pointer, we will perform these operations inside the loop. So let's try writing out the solution right now. So initially I said we have to initialize the res array, and then assign it the value of an array with the same number of elements as the input array. So let's do that. Res is equals to array nums dot length. Now in JavaScript, this will give you an array where each of the elements would be undefined and not 0. And then we'll initialize the res index to nums dot length -1, which means the last index of this array. Then we'll initialize the left and right pointers. So r would be nums dot length -1. Now I said the loop would be while the left pointer is less than or equal to r. And then for in each loop, we squared the number, right? So we would do const num left would be equal to nums l square, and then const num right would be equal to nums, probably should name them like this, JavaScript convention, and then square. So I'll check if num left is greater than num right. This means the left number is greater than the right number. So I will do res index is equals to num left, which means I'm assigning the last position to the num left value, which is squaring the element at the left pointer. And then I'll have to decrement my index. I'll have to decrement my left pointer because we have used up the left element in this loop, so we'll have to increment the left, right? And then we'll do the same. So if it's not greater than the right, that means the right would be greater or equal to left. So if that's the case, what we'll do is we'll similarly change res index to num right, and then decrement the right pointer, right? And then finally, in every loop, we'll have to decrement the index because in each loop, we are assigning one value to the res array, right? So inside each loop, we either assign the left element at the left pointer or the element at the right pointer. And then finally, we'll have to decrement the index. Finally, after the loop is complete, we want to return the array. Now, if our reasoning is right, this should pass the test. So if I hit run code, it does, and then if I submit, we pass the test. Now let's briefly talk about the big O of this solution. So if you notice here, we were trying to get the O of n solution, right? So if you notice here, in this solution, we're just traversing the array once, and for this res, this will always be it'll always start at the last index and then move towards the initial index. So since we're traversing an array once in here, and for every time my input increases, my number of operations will increase linearly. So this will be an O of n solution. So hopefully that was helpful in terms of understanding the problem. If you have any questions, feel free to ask them in the comments or in our Discord channel. Thank you for watching.